Hey, boys and girls, it's Mr. Mac. Today we're doing Module 13, Lesson 2, which is reading and writing decimals to thousandths. So, our I can statement for today is that we can read, write, and represent decimals to the thousandths place. So, the first thing we always like to start out with is kind of what are some of our place value columns that we're going to be dealing with. Today we'll mostly be dealing with the hundreds, the tens, the ones. Then we got our decimal place. And then we have our tenths, our hundredths, and then our thousandths, and I'll put a TH for the thousandths. All right, try that again. All right, and then the H here for the thousandths. All right, so and on the bottom here, I'm going to put THS because remember when we talk about the decimal places, we have the at the end. All right, so this example for the Spark you're learning, it says a digital caliper can measure the lengths of objects to the nearest thousandth inch. How would you read the measurement shown? Describe the place value of each digit. So we have 2.583. Now, we never really read it that way, but until we learn how to really read it, I want to make sure to say just like you usually would. Most of you would read this as 2.583. And unfortunately, that's not how it works. We always read the whole number that's in the front of the decimal, right? So this is our whole number over here. So I have a 2. Okay, so this would be I'm going to write 2 because this is how we would say this. Okay. The decimal means we read and because every decimal is and. And then after the decimal, we still read that like it is a number. 583 is 580. Sorry, my spelling is off today. 83. And then the only thing we're missing at this point now is you always say what place does this decimal end in. So let's look. We have the 5 in the tenths, the 8 in the hundredths, and the 3 in the thousandths. So since it ends in the thousandths here, we would say thousandths. So 2 and 583 thousandths is how we would read this. Okay. A couple key vocabulary terms that we're going to be dealing with here today, guys, are place value, and value. Okay. So when we look at the hundreds, tens, ones, tenths, hundredths, thousandths, those are all the place value columns. So for this example, when it says to describe the place value of each digit, you would say, in this example, our 2 is in the ones place, our 5 is in the tenths place, our 8 is in the hundredths place, and then our 3 is in the thousandths place. Now, if they were asking you the value of these digits, the values of these digits would be 2 is in the ones. That means we have 2 ones. So the value is 2. The 5 is in the tenths place. So the value is 5 tenths. The 8 is in the hundredths place. So the value of the 8 is 8 hundredths. And the 3 is in the thousandths place. So that means the 3 is a value of 3 thousandths. All right, so that's really important when we're talking about the decimal places here. Okay, so let's look at a couple more examples here. So it says, build understanding the Great Pyramid of Giza in Egypt originally stood 146 and 609 thousandths meters tall. Write the height of the pyramid in the place value chart, then represent the height using words. So again, we're just writing down in this box, we have a 1 in the hundreds, 4 in the tens, 6 in the ones, and then a 6 in the tenths, a 0 in the hundredths, and the 9 in the thousandths. So when they're asking us to write it in words here now, like I said before, guys, we're going to write the entire whole number. So we have 146. Okay, then we have our decimal, so we write and. Then we read the whole decimal number, 609, so that would be 609. And what place does it end in? It ends in the thousandths, so we would say 609 thousandths. All right, so that's how we would write this out in word form. So again, you read the whole number and for the decimal, then you read the decimal number, and then tell me what place it ends in. All right, so now we look at a little bit further. It says, do the two digits that are the same in 146 and 609 thousandths have the same place value? So are these located in the same place value columns? No, they are not. Okay. And this is going to tie into the lesson we did previously to this in 13-1, where 10 times the value or 1/10 times the value. Okay. So it says, since the digit in the hundredths place, I'm sorry, before we get to that, I'm getting ahead of myself. So when we look at the 6 and the 1s and the 6 and the tenths, this 6 is one place bigger. So this 6 is 10 times the value of this 6 here, because it is one place bigger. If we were comparing it the other way and saying this 6 compared to this 6, well, this one's smaller, so that would be 1/10 times the value. So I kind of wanted to just tie in the last lesson a little bit before we move forward for the next question. Part B, now I'm on track. It says, since the digit in the hundredths place is 0, can you write the decimal as 146.69? Again, we don't read it that way, but I'm asking, can we do that? And the answer is absolutely not. Because one example, we have 609 thousandths, and the other example, we would have 69 hundredths, and those are two totally different numbers with two totally different values. Okay. So the last question says, to write 146 and 609 thousandths in expanded form, find the unknown numbers, write the expanded form for 146 and 609 thousandths. So this example, the problem tells you in standard form. Then we typed it into word form. Now, if we talk about expanded form, remember, when we talked about expanded form before, we always did digit times place, digit times place. So you're going to tell me the digit, and you're going to multiply it by the place. So I'm going to type this answer out because it's going to be a little bit longer. Okay, so we have the 1 is the digit, and we're multiplying it by the place, which is the hundreds place. Now, I like to put that in parentheses. Let me move this down a little bit. I like to put that in parentheses so that I know that they go together. Sorry, I'm trying to put them in parentheses right now. Okay, I like to put them all in parentheses because I like to make sure they go together. So parenthesis 1. Okay, then the next digit we're adding, and the next digit is a 4. So now I'm going to do a parenthesis, and I'm going to say 4 digit times the place, which is the tens. Then the next digit I'm adding is the 6. We have a 6, and that is in the ones place. So I'm doing 6 times 1. Okay, the next digit I'm adding is another 6. But now this 6, we say 6 times, it's in the tenths place. So we're going to write a fraction, 1/10. That's what I put for my little bar there. Okay. Then I'm going to add again. The next digit is a 0. Now, do I put that in there? No, because 0 has no value. I'm going to skip that. And I'm going to now go on to the 9. And we know the digit is the 9 times the place, which is the 100ths, thousandths place. Okay. So that's what that number would look like in expanded form. Again, anytime you're doing expanded form, you want to do digit times place. Digit times place. Okay. Okay, one more quick example I want to go over because I think this is something that is really important is question number 2. So it says, in building pyramids, Egyptians left a gap between the stones as shown. Would a grain of soil that measures 5 thousandths millimeter fit inside of the gap? So let's look at the numbers that we have here. We have 5/10, so that's 0 and 5/10. And then 5 thousandths means we have a 5 in the thousandths place and nothing else. So now it says to complete the expanded form of each number. So for the gap, we have the digit, which is a 5, and then the place we have is the tenths. Okay. The grain of soil, we have a 5. And then we have the place, which is the thousandths, which is it's a little tough to write with this, but I'll try my best. Okay, so now it says, how does the value of the 5 compare? Well, when we look at this one, guys, the gap is definitely going to be bigger because we have a 5 in the in the tenths place compared to a 5 in the thousandths place. And 5 hundredths is greater than 5 thousandths. But the question is, how much greater is it? Well, we said every time we jump a place value column, so here we had 1 here, we had 2. Every time you jump, it's multiplying by 10. So since I jumped 2 gaps, it would be 100 times the size, 100 times greater. The gap is 100 times greater. So can the piece of soil fit into the gap? Well, let's think about it. If we have a bigger gap and a smaller soil, the soil would absolutely be able to fit inside of the gap there. Therefore, the grain of soil is smaller than the gap. It is smaller. It is 1/100th times the size. It is smaller. Okay. So just something that was a little bit of a refresher, something that we definitely had learned way back in September, actually. Okay. So hopefully this can help you guys with today's lesson. And that's all I've got. Take care. Thanks.